Okay, so here's what we're going to do. This week, we are going to focus entirely, this week we're going to start off by focusing on a really cool lab assignment. If you go over to D2L into the week 11 content area, you're going to very quickly find that we have a really neat, fun lab assignment. Let's just do it real fast. Oops, here we go. The content section, week 11. As you can see, we're building we're going to be focusing on a rocket ship a little bit later for our homework, but for our lab, we're just going to knock this one out because it's going to take not too long to do our goblets and glasses. And I like to start every day off with an activity that gets us back into the mode, right? Gets us back into the groove of making things and building objects in 3D. So we're going to do our goblets and glasses lab. In every sense, this is a continuation of the idea that we established with the medicine bottle. However, we're going to be examining how to create a profile for a curved object using some different tools. With our medicine bottle, it was a pretty simple shape. Well, with both the goblet and the glass, they're more complex, so we need to look at more complex tools that will give us the result that we're after. Ultimately, we're going to be employing the curve tools inside of Modo to help us quickly craft the edge profile that we need to do a radial sweep and create the glass that you see in front of us. You're going to be creating two glasses. They look like this, okay? I've given you the profile curves for both of those guys right there. So go back in time, go back into the Wayback Machine to the process that we set up for the medicine bottle. You got a profile, you created a profile with the pen tool, and then we used that profile as the starting point of that radial sweep. We're doing the exact same thing again, but we're going to be using a different tool, okay? A different tool to create the profile. You're going to be creating two goblets or two glasses. I've given you each profile. You can and should place each goblet in the exact same scene file. If you look at renders number 2 and 3 here, that's a really good starting point for the direction we're going in. Make a nice high gloss portfolio render, make it look pretty when you're finished with the modeling stage of all this, and then submit both your LXO and your JPEG to the Dropbox here on D2L. Oops. Didn't want to hide Modo, I wanted to hide Chrome. There we go. All right, so let's go over into our basic tool tab and explore the tool that we used to create our medicine bottle profile. Does anyone remember what tool we used? The pen tool, and the pen tool is fantastic. We've been using the pen tool a lot over the last couple weeks. It was a major player for us when we began establishing the geometry for the house that hopefully you guys are in the final throes of completing. However, the pen tool has some inherent limitations to it, and let me just kind of draw focus to some of those limitations. When working with the pen tool, and my wall mode is currently on, so I'll turn it off. When working with the pen tool, ultimately at the end of the day, you're always going to get this gigantic n-gon. And the edges are always going to be very straight and incredibly faceted. If you think about what we're going to be doing this week with our goblets and glasses, our glass is nothing but curves, right? I don't want to, use a faceted, sharp corner system to help me create a curved surface. And I definitely don't want to go back in and bevel and do some vertex beveling in here to round out all the edges. That's just an extraordinarily high amount of work, one that I'm hoping to avoid at every single stage, okay? So there's some other alternatives out there that will help us create edge profiles quickly. Now, I'm a big fan of using the curve tools inside of Modo. I think they're quite good. Let's just take a look at them and delete my odd-looking shape here. And I'm going to zip over to my front view just to make it a little bit easier for you guys to visualize how these two curve tool works. The curve tools inside of Modo are a little bit hidden because they're nested inside of the pen tool, this guy right here. It's got a little black triangle in the bottom right-hand corner, which means there's multiple tools nested inside of here. So I left-click and hold. You can see that we actually have two different curve tools available to us. We have the traditional curve tool, then we have the Bezier curve tool. We'll talk about the differences between those here in a minute. Let's just fire off the curve tool. If you go into the Wayback Machine and explore what you learned in like high school geometry, how many points do you need to define inside of your workspace to generate a curve, an arc? 2 is going to get you a straight line, okay? Yeah, so 1 point is just a point. You add another one, it's still just a straight line, right? But the moment we add a third dot into the mix here, you can see that we generate a curve. And because I zoomed in, my curve went all wacky on me, okay? So 3 points define a curve. The curve tool inside of Modo will allow us to very, very quickly create a nice, smooth, fluid, organic shape using all these control vertices. If you look at the technical documentation, we're using what's called a hermite curve. It's been around forever. A lot of apps inside of our 3D modeling world use this hermite curve system as the foundation for generating these special elements inside of Modo. These are unique components, okay? And it is a component type that exists exclusively on a mesh item itself. So I know before today, the only components that we've had were what? What are the 3 basic building block components of all 3D models? It's so easy, it's hard. Not so much the circle, triangle, square idea, although I like that idea. The 3 basic component types of all 3D models. So easy, it's hard. Vertices, edges, and polygons. Those are our building blocks, right? Vertices, edges, and polygons, right? Up until today, I kind of have, illustrated that there's only 3. Well, there's not just 3. There's actually a couple more. The curve is another component type. It's a known component type. It's special. The Modo ecosystem understands what we are creating. It's not a vert. It's not an edge. It's not a polygon. It's a curve. It's a special component inside the Modo world. We have some options that are available to us when we start building these curves. And with the hermite curve tool enabled, check it out. Of course, these are all the ones we have down here. If I wanted to make a closed loop, just make sure that the closed option is turned on. And you can see that those 3 control points have now been transitioned into this lovely kind of rounded triangle. Okay. The modes when working inside the curve tools are also really important. Because right now, if you look very carefully, we're in the add mode over in our tool options, which will allow us to continue to add more control vertices and round out the details of our curve going forward. Much like the pen tool, the control vert that's gold represents the active control vertice, and any new control verts placed along that curve will be placed after the gold one. Right there. I like working with the curve tool because what you're almost always going to get is a nice fluid shape. There's not going to be any 90-degree corners. It's always going to be organic, which is pretty neat. If you look at some of the objects that we're trying to describe this week, the hermite curve tool does a great job of capturing those profiles. Yeah, go ahead.
The profile on your white glass has curves
And corners. Actually, you'll read my mind because I like using the curve tool, but it gets a bad rap often because we can't easily create 90-degree edges, but you can. You can create 90-degree edges by decreasing the distance between the control vertices. Let me show you what I'm talking about. So I have 2 up here. If I get this really close, right in there, now we'll be able to make a very sharp transition. And I'll bring this kind of down over here. There we go. And maybe, just maybe, I'll add another one at the bottom here. So the closer these curves are to each other, you can see that we're generating some nice 90-degree or almost 90-degree transitions. I actually like this because there's almost nothing in our world that has a perfect 90-degree transition. So this is going to infuse small little edge profiles, or small little radiuses within our edge profile that will absolutely be created when we do a radial sweep. Okay? Kind of neat. So the closer these control vertices are together, we're reducing the space, the curved distance between them, and we're able to achieve the illusion of these wonderful, wonderful sharp transitions. Check this out. This is actually kind of neat. I'm going to drop the tool. There's my curve. It's always going to be displayed as this white line. I'm in my polygonal selection set, and as I hover over and click on it, you can see that the entire curve is going to be selected as well. Our standard transform tools of move, rotate, and scale absolutely can and should be used to manipulate the details of this curve. It's a component type, just like any other component type, so we can continue infusing this curve inside of our traditional modeling pipeline. Since it's special, though, check this action out. What if I want to go back in and edit my curve after creation? Since it's special and since it's known to the Modo ecosystem as a curve, selecting the curve and then reactivating the curve tool gives us all those control vertices back again. Check this out. So I have it selected. Whoop, I fire the curve tool off again, and now I can very quickly go in and edit all of my control vertices inside of my curve, which is pretty neat. Pretty fun. Okay. Ta-da! So that's the curve tool. The curve tool is a cousin, a near neighbor to the Bezier curve tool. You're going to get almost the exact same thing. The output of both of these tools is the same. It's just how we go about getting to that output. If you're coming to this class with some experience in an Adobe application or some other vector design application, the pen tool is the tool that we kind of really rely on. We have a pen tool-esque tool instead of Modo called Bezier curve tool. That's really what you're creating when you're creating curves with the pen tool over in Photoshop. You're creating Bezier curves. Works off of the exact same functionality. Notice that my curve at the moment is set to close. I'm going to turn that off just to illustrate its functionality. Click once, you get a dot. You click twice, you get a straight line. But the moment you click the third time, you can see that a curve has been generated. And in addition, we're also getting these lovely tangent handles that will allow us to interactively change the slope on the incoming and outgoing side of the control vertice. At the moment, these these tangent handles are unified. So for this one in particular, selecting one will affect the slope on either side of the control vertice. Much like Photoshop, we can break the tangency of these handles by holding down the control key. Holding down the control key, click, and now we can independently control the slope on either side of the system. You have to hold down the control key every time. These are not permanently broken. So I've broken them, as you can see here, but if I go back without holding down any sort of keyboard modifier and left click and drag, they unify again. So if you want to continue to edit the tangent handles in a kind of a broken mode, if you will, you got to make sure you're always holding down the control key. I love working with the Bezier curve tools because they allow me to very quickly create complex curve profiles with very few control vertices inside of my scene. Okay? And it's a little bit easier to get a predictable 90-degree or sharp transition at the curve locations themselves. I can create some nice, lovely straight lines pretty quickly with the Bezier curve tool. Yes, sir?
So you're going in after the fact to change that into a corner? Or can you do it as you build?
Both. I'm doing it as I build. Let's go to the after the fact idea and show you how that whole thing works. So I'm going to close my curve real fast. Bloop, there we go. Awesome. And I'm going to drop the tool. Now on the surface, it looks and behaves a little bit differently. And if the guys down at the Foundry are listening, it would be really fantastic to kind of, get everyone on the same page and unify this entire process. So when we create a curve with the Bezier curve tool, we select it just like we did earlier. I'm going to activate the Bezier curve tool once again, but this time activating it isn't going to exclusively get all our handles back. With the traditional curve tool, just turning the tool back on gives us all those control points. Here with the Bezier curve tool, we don't get that. Okay? The extra step that you have to do is to click on the curve. Okay? Then you'll get all your controls back. Boop. And all your controls are back. So at no point is this curve completely locked off. We always have an option to go back in and edit the curve at any stage of the game. Yeah.
Sorry.
No, it's all good. It's all good.
So when you're going from transitioning from a curve to a straight line or vice versa, obviously if you click first, then your next click is going to be a straight line, correct? The second point will be a straight line in the Bezier tool.
Not necessarily, but more than likely, yes. Yeah.
Then if you wanted that to be a corner, what command do you do again to make sure that it doesn't make a curve out of it?
So let me just make sure I'm on the same page. So you click once, you get a dot, and you click twice, get a straight line, right? Yep. So I'm creating a new curve. You click the third time, and you're going to get a curve, right? An arc.
I'm not sure that's why I was actually trying to follow and this when you made that corner, what exact action you did.
I just clicked. So I have this dot. I have the one right below it. And then I just randomly clicked on a spot elsewhere, and it made the curve for me, right?
It didn't look like, I mean, from my perspective, it looked like that doesn't look like you had any control over that second corner.
Well, so here's the thing. I control the placement of it, right? The placement of the blue square. And now that I have a third control point in there, I get to go back in and change the tangent handles.
Okay.
Yeah, so you always get to edit your tangent handles after the fact, okay? So I can go back in here now and mess with this guy, right? How do I break the tangent handles? Does anyone remember the keyboard shortcut? The control key will allow me to work with them individually. You got it. It's at the handle, yep. Yeah, I think in some Adobe applications you can actually remove the tangent handles from your control vertices and just... Yeah, this is not as refined as that process. It's pretty basic, actually. But that is the process. It's pretty basic, which is both a good and a bad thing.
Can you change a corner to a curve?
Well, they're always there, right? You never delete your tangent handles. They're always available to you.
Okay.
So, yeah, you don't have to, like in After Effects, for example, you have to convert a control vertice to get that Bezier handle. You always have Bezier handles here. They're never off. Any other questions about working with the Bezier and curve tools? They're pretty neat. They're pretty neat. And what we're able to do in this process, and let me just finalize the thought here. I'll use this guy. I'll turn on my Bezier curve tool once more. Click on my curve. I get all my tool handles back. I'm holding down the control key right now to get a, oops, there we go, to get a straight line. There we go, that's close enough for me. Delete that one. I'm going to turn the visibility of my grid on because I want to make sure that that curve is kind of docked down here at the origin of the scene. So we still want to go in and use the exact same modeling technique that we were working with earlier. Maybe I use a little snapping now to get that control point where I want it to go. Right now I'm snapping to the grid, which is awesome. So I can grab that control point, snap there, hold the control key, snap. The grid snap system is really strong, especially when working with curves. It just makes sense. There we go. Yeah, lovely. And now I'm ready to go, and I can start doing that radial sweep, just like we did with the medicine bottle, right? Select the curve. So under Duplicate, Radial Sweep, I'll change the action center to Origin to ensure that my tool automatically fires off the center of my scene, and there it is. Looks like a bell, an abstract shape, but it looks like a bell, for sure. As you can see with the profiles that we're going to be working with today, these curve tools will help us get to that end result much, much faster. The shapes that we're going to be created are always going to be polygonally based, right? So at the end of this operation, we're still going to get polygons, but how we get there is a whole lot easier and a whole lot faster when using it with the curve tools. Questions? I love the curve tools, by the way. They're going to come back in GCOM 410. I think they're a major kind of structure for the Moto ecosystem. So you're going to see curves a lot going forward. This is simply the introduction to this framework. Are there any questions? Yeah, go ahead. Yeah, they're really great. I like working with curves. I'm going to show you some stuff later on towards the end of the semester that really shows the power of curves. Okay, because if you think about this, we can a curve is really nothing more than a vector path. We can design something in Photoshop, or someone can give me their Illustrator file. I did this with the new Sacramento City logo, by the way. I worked with the designer. I got their Illustrator file. I got their paths. I imported it directly into Moto. It imported as a curve, which I was then able to use as the starting point for all of my extrusions. I didn't have to recreate the logo. I worked off of the exact same geometry that's in all of our print artwork. It's pretty powerful. It's great. Okay, If there are any more questions, what I'd like you guys to do over the next 30 or 40 minutes is to do this lab assignment. It shouldn't take too much effort. I think everyone in here has the skills and the techniques just to knock this one out real fast. I'll walk around, make sure everyone is being served. If there are any questions, we can answer them here in class. And then we'll take a break, and we'll start talking about mesh fusion after we're done with our lab. All right, let's hit it, guys. Okay, so now that we have our lab assignment kind of taken care of, I wanted to spend some time today talking about some new tools that will fundamentally change your perspective and, most importantly, your modeling approach. Okay, as we've explored over the last, almost 11 weeks now, making 3D objects is not easy. It requires a certain amount of discipline. It requires a certain amount of focus and attention to detail, especially when trying to do complex shape modeling like we have here, right? It's a simple square, but we have to put a hole in it. And if you go back in time to your Lego brick assignment, that was not an easy process to do. We were basically trying to glue a circle to a square, and it required a lot of math, some counting, some strategic insertion of polygons in very specific places. I've kind of done the exact opposite here. Instead of growing a little nub from our Lego brick, I just made a hole in the brick. Exact same idea, though. The benefits of this is that we're able to subdivide our meshes pretty quickly and ultimately generate an illusion that looks like, like that. So a perfect circle in that opening, and you don't really see any sort of indication of faceted edges along the model. This is exactly what we're after at the end of the day, right? We want to be able to have this grand flexibility to have a low resolution object where it's very faceted, but then we hit that, bloop, that magical tab key and everything turns into a perfect circle. This is the gold standard, the brass ring that we're trying to grab at every single opportunity. But to get here, especially if you remember the trials and tribulations of that Lego brick, man, it was not easy, okay? It's not that it's impossible, but it certainly is laborious, right? A lot of slicing, counting, bridging, welding points together. It's not exactly an easy, intuitive process. At the end of the day, though, this really is kind of what we want inside of the animation pipeline. It's a nice subdivided mesh. The polygons are very evenly distributed across the surface. It's not a zillion polygons just to make a hole inside of a square. This is what we're after at the end of the day. How we get there, though, is now changing. I'm about to introduce some ideas and some tools to you guys that will allow you to create this shape quickly, but at the cost of your polygonal count. There's a new tool inside of Fusion, or a new tool inside of Modo, and it's not actually new. It used to be a plugin, and it's called Mesh Fusion, and it's pretty fantastic. Before we get started, though, it's really important that I underscore this idea that Mesh Fusion is not a replacement in any sense of the ideas and topics that we've been exploring up until this point. It's an addition to our tool set. It's another tool in the toolbox. Personally, I find Mesh Fusion it's awesome. It's pretty fantastic. It allows me to freely conceptualize the form of my sculpture without having to wonder about polygonal flow and counting and bridging and all that jazz, right? It allows me to truly be a sculptor inside of Modo in the hard surface world. But with everything, there are pros and cons to everything, right? To every single technique and approach. The Mesh Fusion system allows me to get to this shape in about 3 clicks, okay? But at the cost of my polygonal count. At the end of that process, I'm going to generate an object that is 1,000,000 polygons. Mesh Fusion, in my opinion, is a conceptualizing tool. It allows us to explore quickly and see what the overall shape is going to be, with the idea that we're going to go back in and retopologize this shape after the fact to ultimately get it back down into something that looks like this. An evenly distributed polygonal cage model that doesn't have a zillion polygons on it for a cube with a hole in it. So it's a conceptualizing tool. At the moment, in my opinion, Mesh Fusion is really designed to conceptualize quickly, get to the end of the concept stage so that they can then be turned over to someone like me and I'll make the darn thing, a production artist, okay? Let me show you how it works. It's amazing. I love Mesh Fusion. I use Mesh Fusion a lot. And your homework assignment this week is going to allow you to play inside of this sandbox and create a really cool rocket ship. We'll come back to that here in a minute. I want to do some things very quickly, and I apologize because I just want to show you the benefit in the workflow of Mesh Fusion. But of course, we're going to go back in and talk about each one of these steps after the fact. So I want to build it real quick, and then we'll really dig in deep and talk about specifics of the actual tool itself. Make sense? So if you go, oh, I'm lost, that's okay. We're going to come back. We're going to come back and talk about each step very quickly. The Mesh Fusion system allows us to do live booleans. We've been talking a lot about booleans. They're a nice addition to our workflow. You worked directly with them when you were building the house model over the last couple of weeks. But as you probably experienced with the house, man, once you sliced and cut those holes in the walls, it's somewhat permanent, right? It's not a great workflow. But it does very quickly allow us to cut in very custom shapes into flat polygonal surfaces. Mesh fusion is a Boolean operator, but it works at the item level. So we're going to be taking complete items and subtracting and adding their shapes from other items inside of the scene. They're items to items. Each one of these mesh items needs to be comprised entirely, and I mean entirely, with Catmull-Clark subdivision surfaces. Now, when we talked about sub-Ds a couple weeks ago, I mentioned that there's two different algorithms that we have access to inside of Modo. Let's review and refresh just so everyone's up to date and has a really nice hand on what all this looks like. I'm just going to add let's just do a simple sphere. There it is. Okay, simple sphere. Here's the straight up polygonal object, right? Now look closely at my cursor. What color is the rollover highlight color for this polygon? Blue. It's a blue. It's a light blue, right? Whenever you see a blue polygon, you are in a traditional polygonal mode, right? So you're seeing a traditional polygon. If we were to hit the tab key and apply the subdivision surface algorithm to our mesh, what color is the rollover highlight color now? It's interesting because it looks kind of pinkish to me, right? I think this projector is washing out the colors a little bit. On your own local desktops, and especially on my iMac up here at the front, it's kind of pink, okay? It's a pinkish hue, okay? So when we see the pink, what we're ultimately seeing is a subdivided polygon. All right, so I've gone back. Now I'm working with traditional polygons. Now check it out. We want to work inside the mesh fusion system with mesh items that are using the Catmull-Clark subdivision surface algorithm. And this is the granddaddy of all the sub-D algorithms. This is the original one. This is the algorithm that the folks down at Pixar use. It really is quite powerful. And we get access to it here inside of Modo. Let me show you how we need to transform this traditional polygonal object into a Catmull-Clark subdivision surface object. And it's really easy. The modifier that we need to enable is Shift Tab. Once we do Shift Tab, our rollover highlight color kind of goes a green, and this is what we're after. For Mesh Fusion to do its thing, we have to be working with mesh items that are comprised entirely of Catmull-Clark subdivision surfaces. So Shift Tab, okay? The system fundamentally just won't work if you're using the Loxology, subdivision surfaces, okay? In addition, we also have to have mesh items that are comprised entirely up of quad polygons. And as you can see up here at the top of my sphere, we don't have quad polygons up here. What do we have at the poles? Triangles, right? So this is a no-go, uncompliant mesh. We have to have all quad polygons across the surface of our geometry. That's a rule. It's a hard and fast rule for the mesh fusion system to work. It's got to be Catmull-Clarks, and it has to be all quad polygons. So there are a number of different ways that we can get to our result here. I'm actually going to delete this thing, and I'm going to show you some presets that already come enabled. They're already Catmull-Clark sub-Ds, and they're already entirely quad polygons. Okay, I like this. They're mesh presets. You can find the entire fusion system in your in your modeling layout. And it's way down here at the bottom of your toolbar. Get a tab that says Fusion. Let's go ahead and click on that tab. And up towards the top here, under the Fusion Meshes category, we have this guy, Cubic Geometry. If you open this, you're going to probably get one of two different things. You're either going to see this little popover form as you see it here, or it's going to look like this, okay? This is a preset library. It's going to a very specific location inside of your computer. If this is what you see, where you want to go is into the Fusion Meshes folder. Let me just click on it. And then Cubics, and here's all the mesh presets. Okay. Now these are all ready to go, and I think I'm just going to use the barrel. And let's do this. I'm going to hit undo. And I'm going to rebuild the example that you saw a minute ago. So I'm going to grab that one, and And I'm also going to double click on this cylinder. Okay. I'm going to turn off the visibility of my cylinder just for a minute. And in item mode, because Mesh Fusion works at item mode, I'm going to duplicate the square, make it just a little bit smaller, and move it up so I can examine the thickness of my walls. Okay. Here's the cylinder. In every sense, this is going to be the element that's going to cut the hole. Okay. So really what I'm going after here is a recreation of this example. Okay. All right. Let's go ahead and do it. Now, again, I'm going to do this real fast. We are going to come back and revisit this, but I want you to see the benefit live and quickly in front so you guys can get excited about it. Okay? Now, Fusion works on an item-to-item level. So I'm in item mode, and I'm selecting my items in very specific orders. And I'm going to create a new Fusion item, and I'm going to subtract the cubes from each other. There we go. Now we have a hole in my cube. Okay? Now what's also kind of neat is I can grab my cylinder here, make sure it's not going all the way through the back, and I want to subtract it from my guy. And there we go. Turn off the visibility of my source meshes, and you can see within a couple clicks I've completely recreated the example that we had inside of preview. This is the structure that we use in the Lego brick assignment, and I've basically done that exact same structure with Mesh Fusion with a couple mouse clicks. Now, this is really neat. I like it. What makes this even more awesome is the following. Let me turn on my source meshes again. And actually, I'll leave it off so it'll be a little bit easier to see. I'm going to grab my cylinder here and check it out. These are live booleans. Yeah. These are live booleans, so I can make wholesale changes to my meshes pretty quickly, and I always have an opportunity to go back in and change that at any time. It's pretty great. Yes, sir?
So what's happening right now is, because that cylinder over there is what's selected, when you're moving it around, it's just kind of ghosting it in that area in a way.
Yeah, kind of. If you really look at what's going on, right now I have all of my source meshes disabled, their visibility turned off. There's the actual cylinder itself. So wherever that cylinder is intersecting the cube, it's subtracting the volume of that cylinder in that area. It's rad. It's very rad. Okay. Of course, all of these ideas are live, so I could even go back and do something like this if I wanted to. Make my cylinder, oops, wrong way. Yeah. I mean, that's just pretty great. I mean, try modeling that quickly using the traditional loop slice process. It's not easy. It's pretty great. Okay, let's do this. Let's create a new project file here, and let's actually go through the process and dig into specifically what you need to do to create this new Fusion item inside of the Modo modeling world. Okay, it's pretty easy, and as we described earlier, what it really boils down into is the infusion of mesh items that are all quad polygons, that are all Catmull-Clark sub Ds. I'm going to go back to my cubic geometry here. And let's do this. I think I'm going to make like a cool like jet engine type thingamajig. And I'm just going to freestyle this. I have no idea where I'm going with this process. So let's just add this in. So that's going to be the base of my jet engine. Okay. And let's do this. I think all jet engines, of course, need to have some sort of opening in them. So let's do this. I'm going to add that one into the mix as well. And I'm going to start to position them where I want them to go. Maybe a little too small. Okay, that's a good start because we can always go back in after the fact and change how this looks. Okay, so now I have the outside of my engine, and then this cone is going to cut out the inside of the engine for me. To create the Fusion item, we have to initially begin with a selection. And just don't select things willy-nilly, because what you select and in the order that you select them actually plays a big role on the next step. I always select my base first. So in my case, it's going to be the little bullet type shaped thing at the top. So I'm going to grab that one. Then holding down the shift key, I'll grab the one below. Awesome. And I'll create the Fusion item. So at the top of our Fusion toolbar, we have this option here that says New Fusion. You click on it, you'll get this little flyover form. Let's give it a name. Let's call this Pat's Groovy engine. And then we have two different options, or two different Fusion items that we can create. We have the 3D tree fusion and the schematic fusion. Now for this class, we're going to work entirely inside of the 3D tree because it's really easy and it allows us to work extraordinarily fast. In 410 and maybe even in GCOM 424, we'll look at the schematic fusion, which allows us to nodally connect all these pieces together and create very complex yet controllable results. It's uber advanced and we're not even going into it today. The 3D tree is definitely the easiest way to do it. Okay, now down here where it says create new fusion item, this is why I asked you to be really careful and understand the selection order a minute ago. So I'm going to subtract everything from the first selected object, which was the outside of my engine. It's going to think about it for a second. And there we go. Okay, get out of that form, and there's the inside of my engine ready to rock and roll. Now that we have a basic fusion system going here, let's talk about some of the really important ideas inside the Fusion tool area that we need to be aware of. First and foremost, visibility. We have a couple of visibility options that you need to know. Source mesh visibility. If you turn that on and off, you can see that the source meshes, there we go, off and on. Great way just to get those things out of the way so you can see exactly what you've created, so that's cool. You can cycle the opacity of all of your source meshes as well. With now they're kind of this tan color, and now they're slightly lower, and then now they're almost 100% transparent. So different options here to make it a little bit easier to see what exactly the Fusion item is creating for you. Fusion view settings, that's going to turn your work plane on and off in the background. Okay, and it's also going to display all the wireframes for your Fusion item. And here's the problem that we're working with, right? You can see exactly what the Fusion item is going to create for us. It's going to be a heavily subdivided mesh. There's a lot going on in there, a lot of polygons. So this is the big takeaway with Fusion. You're able to very quickly create conceptual shapes, but you're always going to get a pretty high resolution mesh object. Okay. The alt viewport settings are basically going to take off all those visibility options for you. Okay. All right. Okay, I want to turn off my work plane here real fast. There we go. Okay. There we go. All right, so to continue working here, I need to have the center of my engine go all the way through to the outside, right? Because right now it just kind of looks like a cup. So let's go ahead and add an additional player into the mix here and continue adding source meshes into our Fusion system. So I'll go back to my cubic geometry preset library, and I think I'm going to grab just this little cylinder here. Of course, I'm going to scale it down. Let's figure out maybe somewhere right around there. There we go. Cool. Now, this 3D tree is really important. This 3D tree is more than just a visual representation of how the entire Boolean system is working inside of our Fusion item itself. It's a tree means so that we can accurately and continue to use our Fusion system inside of our modeling workflow. The data flow, in my opinion, starts over here. These are instanced, just visual representations, if you will, of all of our source meshes. You can't really work with them outside of selecting. Okay, they're a really great way for us to select our source meshes, but we can't really move them around. It's just really kind of a selection medium. It tells us specifically the role of each one of our Fusion meshes as well, especially when we start looking at this next row. So we start here. These are all of our source meshes. This next row is really important. Operators. These are what's physically doing the work inside the Fusion item. The green guy up here at the top is the union node. This next row of dots are all the boolean operators. These are what's physically doing the work inside the Fusion item. The green guy up here at the top is the union node. So if we wanted to glue meshes together, that's the operator that we're going to have to work with. The blue dot in the center is intersection. The red one at the bottom is subtraction. If you kind of use this idea, you can start to decode specifically how the Boolean system is working, right? We have that bullet shape up there at the top. It has a line being drawn from its source mesh to the green dot. Everything is initially associated with the union operator. And then down here at the bottom, we have this cone that's being subtracted from the top guy. Make sense? Yeah. So once you start getting your hands dirty with it, you'll get a little bit more comfortable with it. Okay? Bingo. Let's keep going because there's a data flow from the source meshes on the right through the Boolean operators. This cyan guy here, this is a branch operator. And you will see this in play here in about 10 minutes. We can have multiple branches of Boolean operators inside of our Fusion tree. Again, we'll come back to that in a minute. And then finally, this green dot way over here on the left, this is a representation of the actual Fusion item itself. So we start with our source meshes. Those meshes are flowed into Boolean operators, which are like tools, if you will. Those tools are controlled by the cyan dot, okay? And each branch then is finally fed into the Fusion item, which creates the mesh, okay? I'd say most of the time, you just need to keep your eye on these little dots, because these dots are tools, okay? They're really a visualization of a tremendous script library that physically does the work of subtracting and adding and of all these items inside of our Fusion element itself. So I want to subtract this little cylinder from my Fusion item. Let's do it real fast, okay? So I want to drag it. Check it out. This is interactive down here. I want to drag my item, and I want to place it right on top of that red dot. Just real quick, bloop, check it out. Boom. It subtracts that cylinder from the tree, which is pretty cool. Now, it looks like we're getting some funkiness here because of the size of this guy. So let's experiment making it bigger or smaller. Well, that's definitely not working. Here we go. Yes, that's what I was after. Wonderful. Wonderful. That's cool looking. Now we're starting to make it look more and more like a fun little engine, okay? Let's do it one more time. I'm going to go back to my cubic geometry presets. And I want to add in this little hockey puck guy. And I think I want to make just a fun little pattern up here. Okay, somewhere perhaps right around in there. Yeah. I want to add this to the outside. I'm going to glue it to the outside of my engine. Notice, however, that this donut is intersecting the opening shaft, if you will, of the engine. Keep that in the back of your minds, because that's an important little nugget to hold on to. So I want to add the donut, this little disc, the hockey puck, into my system. I want to glue it to the outside. So I want to drag and drop it on top of the union node, the green guy. And boom, there it goes. Let's turn off the visibility of our source meshes. And there it is. It's looking pretty great. Let's go on the inside, though. Interesting. We're still getting that shaft. Inside of the Fusion system with a single tree, we're not getting an order of operation. All of the source meshes are being evaluated by the Boolean operators at the exact same time, which is why we're getting that hole through that disk, okay? Making sense so far? Yeah? It's pretty cool, right? What's groovy about Fusion is, of course, we can go in after the fact. I've selected where my source mesh is. I've hit the Y key to bring open the transform tool. And I can go ahead and continue doing some art direction. Maybe I don't like the placement of this thing. Maybe I want it maybe more up here. scale it down some. Yeah, that's pretty cool. Maybe that's a little bit more what my creative brain was going after. Okay. So you're always able to change the location of these fusion elements whenever you want. It gives you a tremendous amount of freedom and flexibility inside of your modeling workflow, and I think it is just absolutely game-changing in my opinion. Okay. Now, as you hover over your mesh when working with Fusion, from time to time, you're going to see these little blue rings pop up, and I haven't updated my strips in a while. There's one down there. Let's talk about these blue rings. These blue rings are called strips, and these strips are created every time we add a new Fusion source mesh into the Fusion item itself. I only have one at the moment, and I've done a lot of work. So, good habit to get into is to update your strip items. Update it. There it goes. And now I'll have these rings around up here. I'll have them up here as well, where I was making the circle. Now, what this is, see, once I select it, you can actually see the quad strip that's being infused on the mesh. You'll get this groovy little HUD. These are sliders down here, by the way. And I can maybe increase and decrease the width of that radius, which is pretty cool. I can change the profile to make it more sharp or more smooth. Okay, so we have a lot of modeling control over those strips even after the fact, which is pretty neat. But don't forget to update your strips every now and again to get access to all of them. The computer is going to register the creation of strips at every time you add a new source mesh into the Fusion item, but they're not going to give you access to them until you update your strip items over here in your toolbar. I think that's just really neat. Huh? It is. This is a game changer, folks. It really is. I don't like hyperbole. I really don't. But this changes our approach for modeling. Being able to have this live interactivity with our shapes and not have to really focus on the polygonal shape itself, on the loop structure, and the polygonal flow of our objects is pretty redonkulous. It's pretty great. Okay. Let's have some fun here. Maybe as I start to go in, maybe I want to create some really neat bevel details around the outside of my engine here. And let's do this. Let's go into my cubic geometry preset library, and I really don't know what I'm doing here. Let's see. I'm just kind of freeforming it. Let's use this cone. I'm going to scale this guy down a little bit. And I'm just experimenting. That's all I'm really doing here. Experimenting with shape. I'm experimenting with form. Maybe I rotate this a little bit. Yeah, let's just see what that looks like. Okay. Let's subtract this from my system. I'm trying to create a cool little pattern on the side here. Yeah, that's awesome. I mean, try modeling that, by the way. That's actually kind of difficult to model. And getting the correct curve and radius and all that jazz. It's pretty cool. Now that I look at what I'm getting here, this is exactly what I'm going for. But maybe I want a whole bunch of these going around the outside of my little engine. Turn the visibility of our source meshes on. Now, up until now, I've been mentioning that we're working at the item level, and you're absolutely correct. The Boolean operation happens at the item level. But that doesn't mean we can't go in and work with our source meshes at the component level. Check this action out. This is actually pretty cool. I'm gonna select the polygons on my little cone here. There we go. I'm gonna select all of these guys. I want to change my action center to origin, and then with my duplication tools, I'm gonna do a radial array. And I only need 4 of these guys. Clicky click. And you can see that now, since I've duplicated a component of the source mesh, they're also getting removed from my guy, which is pretty rad. That's pretty cool. So we can continue to work with these, with our source meshes in the component level to do duplication, to do any sort of deformation, to get a custom look and a custom feel. That's absolutely something that's inside of our purview and control, and something that the system allows for us to do. All right. Now, I'm not digging how the bottom of my guy is working out down here. So let's do this. I'm going to go back in and let's get the hockey puck back. I'm simply going to move this down. There we go. And then subtract it from my scene. There we go. And now I just have a nice crisp bevel down there at the bottom. Awesome.
Do that without subtracting? Just kind of like maybe level out that work there?
No, yeah. Yeah, nope.
Fusion is all Boolean.
It's all Booleans. That's all we're doing. It's all Booleans. Yep. All right, so here's what I want to do. I want to create maybe some like scoops along the side, maybe like air intake scoops for my engine. The base is going to be the opening of my engine, and this is kind of like a turbo, you know, a jet engine, okay? So I want to maybe create some big air scoops going around the circumference of my engine. I think I'm going to create that with a cylinder. Let's do it real quick. Back to my preset library. I'll use my favorite medium-sized cylinder, scale it down until I'm getting kind of approximately what I want. Okay, now I'm going to change my action center to selection so I can start sculpting its placement inside of the scene. I'm really trying to figure out where I need to move and rotate this to get the result that I'm after. Maybe I make it a little bit longer. Yeah, that's close to what I'm after. Yes, that's exactly the shape that I'm after. Okay. Oops. Didn't mean to select my. Okay, that's it. That's the size of my scoop. Okay. But a big air scoop probably needs to have an opening in the center, right? So I'm going to think ahead 8 or 9 steps, and I'm going to duplicate this cylinder and scale it down. That way, they're both in the exact same spot. So, Control D to duplicate the mesh. Make it a little bit smaller, move it down along the y-axis. And what I'm doing here is just defining the thickness of that air scoop. There we go. That's exactly what I'm after now. Now's a good time to save my project file. I don't want it to crash, and sometimes I've noticed that the next step here is going to cause a crash. All right. So now I have a challenge placed in front of me. I have this outside piece and an inside piece. This outside piece I want to union and glue to the exterior of my engine. And then I need to subtract an opening inside of that scoop with the smaller cylinder. Okay? Check out the challenge. Now, I'm intentionally going to do this wrong to show you why we need to do this branching system. Okay? Let's do it. Okay? So I'm going to add the outside scoop piece as a union operator. Boom. It gets glued to the outside. And that's exactly what I want. Beautiful, right? Try modeling that. Again, that's one of those things like, that's pretty difficult to model. Now, to create the opening for the engine scoop, I want to take this guy and subtract it from my mesh. Not really what I'm after, right? Because if you look at the way this opening down here, it doesn't look like a scoop. It doesn't look like it's been glued to the outside. It's actually drilling a hole into the interior of my base. Not what I'm after. This is not the result that I want. I'm going to hit undo a couple stages and get my scene back to the state before I did this last operation. And I'm going to show you a new option. Ultimately, what I want to be able to do is isolate this scoop from the rest of the model and only have the Boolean operators of the scoop affect only have the Boolean operators affect just the scoop, nothing else, okay? I don't want to drill a hole onto the inside of my engine piece here. Let me go back in time a couple steps. There we go. All right, now this next bit is going to require us to create a new branch inside of our 3D tree. There's a couple things that we need to look at carefully here in order for the branching system to work correctly. First and foremost, we need to have the visibility of all of our source meshes on. Bloop, there they are, okay. Now, the next thing that we're going to do is that we're going to do a quick drag and drop onto the base mesh itself. So I'm going to grab my cylinder and a quick drag and drop. If you hover for any period of time, you'll get this popover. This is the wrong popover, okay? So the quick drag and drop looks like this. Drag, drop, and when you mouse up, this is the option, the popover that we're after. It's a great method for us to very quickly do union, subtraction, and intersection operations. But check it out. Now we can do new branch with union, new branch with subtraction and intersection. And let's check out this. I'm going to do a new branch with union. It's going to think about it for a second. And watch what happens to my 3D tree. Boom. Okay? Turn off the visibility of my source meshes. We're still getting the exact same result that we had before, but let's look at my 3D tree. We've now created a new branch that isolates this engine scoop from all of these pieces. Okay? What this is going to allow me to do is to control that engine scoop separate from the rest of the model. We also get that same interactive, the interactive dots that we had before. And now, check it out. I'm going to grab this guy, and I'm going to drag it into this this subtraction node. It's going to think about it. Ha-ha! Ladies and gentlemen, that's what I was after. See how it's not drilling a hole onto the interior of my, my base anymore? It's only subtracting that cylinder from the other players of that branch. We've isolated it. It's very cool. It's very cool. Yeah, me like you very much. Shoot, while we're here, might as well do that exact same component level duplication that we were working with before, right? So there's the outside. I'll grab its polygons real fast. Change my action center to origin, and then do a simple radial ray. So now I got 4 engine scoops. Let me grab the interior piece here, its polygons, and also do a radial ray. And I've subtracted everything. As you can see, working with Mesh Fusion allows me to iterate pretty quickly. I can conceptualize, I can start throwing all these pieces together inside of my scene and create something that's pretty rad pretty quickly. If I wasn't teaching this right now, this is probably about 5 minutes worth of work. Using a traditional modeling pipeline, this is hours of work, okay? Hours. Hours upon hours upon hours.
And you were saying, we're conceptualizing, so let's say you were to actually go in and make this and turn this in if you want us to do it in the traditional.
No, there's no reason we can't use the meshes that are generated from Mesh Fusion. Okay? You will still get an airtight compliant mesh that will render correctly. You can still incorporate this into our normal rendering pipeline, so materials and textures, that's all good. I'm about to show you that stage here in a second. Okay? However, if this was something that's going to be animated, okay, if we needed to deform this, we need to have a discussion about it. Your production team needs to have a discussion. Okay? Because what you're going to get is a ridiculously high resolution object at the end of this process. Okay. Now, with Mesh Fusion giveth, but it also taketh away. Where Mesh Fusion breaks down, in my opinion, is when we do high detail kind of booleans very close to one another, because those strips are going to get in the way. And let me show you a really great example of this. This is not the ultimate tool, but it is a good one. Let me do one more thing. I want to make my engine look a little bit different up here at the top, and I'm going to use another preset. How about we use this little triangle guy? There it is. Let's move it up. I'm going to make it much smaller. What I'm looking to do here, again, we'll make it much, much smaller. Maybe something like that. Oops, I don't want to go going all the way through. Sorry, I'm being a modeler. There, okay, we'll have it go all the way through. All right, and now I'm going to do that radial array one more time. Let's see, we're doing duplicate, radial array, and this time I want a lot of them. Let's put like 16 of these guys in here. Yep, that's good. Okay. Now let's go into item mode, and I'm going to subtract this from my original tree way down here at the bottom. It's going to think about it for a while. There we go. Okay. Interesting, right? But we have some big time problems in here. Let me update all my strips. There we go. And now I have some issues. Some big issues in here that I need to work with. Because the strips up here at the top, yeah, I'm actually having a problem getting the strips up here at the top. So let's select all the, yes, let's update it. Strip mitigation is kind of a big thing. I think it's the area that they need to work on the most, in my opinion. Yeah, it drives me crazy that I can't, there we go, that I can't select, and look at the bottom here. That's a problem. I need to make that much, much smaller. So whenever you have your strip selected inside your Properties tab, you look at this little series of options, and I'm going to define a new width because I'm not getting that popover anymore. So I'll make these 2.5%. There we go. That's better, but we still got some issues down there. So it's not perfect in any sense. Okay, it's not like parametric modeling that you see in CAD applications. There are some very defined limitations to this workflow, and it can cause problems. Okay, I like to think that Mesh Fusion is perfect for what I've done basically on the bottom side of my engine. It allowed me to conceptualize a complex shape and organic form with basic building blocks quickly. The high resolution detail stuff is maybe something we should explore a little bit later on. Okay. So what do we do with these Fusion items? Okay, we're not quite done yet. We spent some time building it, but we got to get it out of a Fusion item and into a Mesh item. If you explore the contents of your item list over here, this is the Fusion item itself. It's a unique item. It is not a Mesh item, even though it contains geometry on the interior of its container. Okay, so we need to convert this Fusion item into a Mesh item so we can continue to work with it inside of our standard production pipeline. With our Fusion item selected, our Properties tab is going to yield a whole series of options that we'll definitely want to look at. We're going to jump all the way down here to the bottom where it says Fusion Mesh. Because check it out, the default mesh mode is draft. What we're seeing inside the OpenGL viewport is a very quick, rudimentary, unrefined representation of what the Fusion mesh item is trying to create. It's a low quality interpretation of all these Boolean operations. If we change our mesh mode to airtight final with parts, for example, Now we're going to get a representation of what the actual finalized mesh object is going to look like when we convert it. Yeah, and you can see we have some issues in here, a lot of issues in here. Okay. The high frequency stuff doesn't work too well, but overall, I'm generally pretty pleased. All right, the last step in this process, and if you have UVs, we haven't spent a lot of time talking about UV maps in this class. I saved that content for 424. But if you have UVs and you want to continue using those UVs, just make sure that's on. Now, the last thing that we do is that we output our mesh, and we have a couple options in here. We have duplicate and convert our fusion item to a mesh. We can just duplicate our fusion item if we wanted to, and then we can convert our fusion item to a mesh item. I like dupe and convert because it's going to duplicate the original fusion item and then convert it into a dedicated, unreferenced, self-contained mesh item. This leaves all of our source materials in our project file. So if we ever need to go back and make a change, all of that stuff in that engine is still available to us. It doesn't get rid of the fusion item. So let me hit the button here. You'll get a little pop over on the left. And we'll just, here's the name of it. Of course, we want to duplicate the original. We want to merge all the vertices to create an airtight mesh. And we also want to create the material groups. And this is going to come into action here in a minute. Finally, create the mesh. You'll think about it for a second. There it is. And there is your traditional mesh item, active and available for you to play with instead of your scene. If you look at your item list, check it out. Your fusion item itself has been turned off, and what's active, and the only thing that's active is the new dedicated, unreferenced, independent traditional mesh item. We still have all of our pieces, and all of those pieces are still connected to this fusion item, so we absolutely have an opportunity to go back in and change things if need be. Ta-da! Let's go over to our render tab and explore this for a second. So there it is. Here's Pat's Groovy engine, looking pretty great. However, I want to make some pretty big wholesale changes to my render here. Maybe I want it to have be kind of like a silvery exterior, and maybe each one of those air scoops is like a different color. And then maybe I want to have like a gunmetal gray for that top bit and the interior core. Selecting polygons instead of a fusion system can be a little bit troublesome because there's a lot of them, right? This is what I don't want to do. I don't want to have to do this. Polygons, right? This is not how I like to spend my evenings, right? This makes Pat grumpy. Yeah, I can even, I can do that, make it a little bit better, but still, I don't want to have to go in and hand select each one of these polygons. No way, man. No, thank you. Well, when you duplicated your mesh fusion item and created an independent mesh fusion item, there was an important option down here. It was create material groups. When this is enabled, Mesh Fusion is going to go in and create a material group. There we go. They're going to create a material group for each area that was added or subtracted from a source mesh. Okay? Let me show you what this looks like. I'm going to go into my material selection set. Boom, right there. And now when I start to roll over, of course, it's going to make a liar out of me today. Oh, you little dork. It didn't actually make all of my materials for me, even though I had it on. This makes Pat a very grumpy guy. Let's do this. If I grab, yeah, it didn't make the materials for me. How dare you? Let's try it again. I'm going to delete my mesh item. I did hit delete, right? Delete. Oops, I didn't click on it. That's my fault. Delete. There we go. Let's go back to my fusion item again. Okay, let's try exporting it one more time. Dupe and convert, duplicate, merge vertices, create material groups. We'll create the mesh. Let's see what happens. Mesh Fusion is not without its bugs. There's some consistency problems in here. Did it create my materials now? No, it still didn't create my materials. I know this because none of these are all the material presets that come with the preset, the mesh presets, okay? This is mission failure for me, or this is Mesh Fusion mission failure. I ran this exact same example on my Tuesday section, and it worked fine. However, there is a workaround. Let's see if the workaround did, in fact, take place. Let's go in. I want to show you the back door into Modo's selection system. It's in the Lists tab. And under your Stats area right here, we can actually start to break down. Let's go into Polygons. Nope. Let's see. Nope. Fusion Surface. It really didn't do a single thing. Well, that's a big-time bummer for me. That makes me grumpy. Yeah, it assigned all the fusion polygons to one material, which is not what I wanted at all. Grr. I'll have to figure out, maybe there's something that I'm doing wrong, but I'm pretty sure I'm not, and get back to you. Yeah, see, and it worked for me on Tuesday just fine. Whenever it should have assigned a material to basically all of those polygons in that little cone shape, you know, but it didn't. It didn't. This is usually the time of the day when I reset Modo and quit Modo, open it back up again, and try to maybe re-export my model or reconvert my model to get all those material groups. Let's see, did it make all my UVs for me? I bet you it didn't even do that. If I have UVs, that's something I can use. Yeah, so at the very least I have all of my UVs. That's good. Because now I can use my UVs over here as a material selection. We'll just call this base. Call this gray. I'm going to assign those to the gray one as well. Gunmetal gray. That's base. See, these are all the little scoop guys. So I want to do those. Huh? Pretty cool, huh? Yeah, let's see. The rest of this, where are these guys? Let's do this. I'm just going to globally select as many of those as I can. Assign them to that gray material. Hide them. And then the rest of these are basically going to get assigned to that base color. I'll unhide everything, return to my render environment. Let's take a look-see. Yeah, okay, now we can start working the base. Let's do this. I want to remove my diffuse amount, the diffuse color. Oops. Let's do specular amount. This is the reflection. Make it a very dark, dark gray. Kind of getting into that aluminum world, which is what I want. Here, let's put a cool material environment preset in here as well. That way, we'll start casting some really cool reflections. Yeah, there we go. Now it's looking a little bit more reflective, which is neat. Okay. The gray, I want this to be very undiffuse as well. Pretty dark, almost black. And I don't want it to be very shiny at all. A little bit shiny, though. Not very little Fresnel. That's an idea. I don't know. I'm still experimenting. A little too reflective. Let's put our roughness back up to like 80. It's interesting. I'm just playing around. And then, of course, red. This is kind of fun. Let's put this down to 0. And the specular color, let's make it a nice red. Yeah, actually, let's put our diffuse up to like 10%. So, oop, nope. Let's put this back down to like 1. There we go. And then specular amount, let's make it kind of shiny. Maybe a little too shiny. There we go. Yeah, kind of a fun, almost looks like a Christmas ornament. Futuristic Christmas ornament, right? Futuristic Christmas ornament. Kind of cool though, kind of fun. So we still get to work with these meshes in a traditional rendering environment. We're working with polygon tags for materials, and life is good. Life is good. All right, questions about working with Mesh Fusion? Yeah. To make the new branch? Yeah. This is a problem. I've even mentioned this to the Foundry guys, because the speed in which you do a drag and drop should not determine the which popover you get. It makes me kind of grumpy that they have designed the engine that way. It's actually 2 different drag and drop systems competing with each other. Okay, so let's put in a, I don't even know. I don't know here. What am I going to do? Let's do this cone. Why not? Let's see what happens when we do this cone. Whoa, it's really big. And maybe, I don't know. I'm clicking on the outside rings. That's the scale tool, yeah. I'm clicking on the R key on my keyboard. Yeah, the W key is move, E is rotate, and R is scale. I have no idea what I'm making, by the way. I'm just having fun. Okay, cool. And so these give a little something. Maybe I'll chop the end off with a square. I don't want a spike there, but maybe I want a cool. Let's grab this guy. My favorite hockey puck. I'll scale down. Whoops, that was fun. Okay, there's my fun little shape. Yeah, it's a gas cap. So now, okay, so here it is, Vincent. This is what we got to do. So we got to turn your source mesh visibility on. Okay. So there, all of my source meshes come back on, and we need to grab the new source mesh item that we want to put on its own branch. In my case, the base of my gas cap. So I'm going to grab it. I'm going to drag and drop it onto the base, and I'm going to let go pretty quickly. Okay. The base is the initial item that we selected when we created our fusion item. And I'll do new branch with union. Did it crash? When you start adding a ton of fusion items into the scene, it takes longer and longer and longer to evaluate. Mine just updated. So I got a new branch way up there, and then I'm going to add this one as a subtraction node. Yeah, my dorky little gas cap. Okay, I shouldn't do this, but I'm going to do this. So I'm going to duplicate that item. Turn on the duplicate. Oops, I grabbed the wrong one. I wanted the cone. Right? Yeah. Control D to duplicate it. I'll move the duplicate out. Might help if I turned it on. There we go. Let's see if I can subtract it real fast from the outside. Yeah, kinda. It kind of worked. Awesome. Fun times. My dorky little gas cap on the outside of my guy. Okay, questions on how to work with Fusion. I want you to play around with it. This is a week of exploration because the Fusion tools give us a lot of opportunity just to explore form and explore volume and shape. This week's homework assignment is a real fun, easy one. It's a rocket ship. Make me a rocket ship. I've given you some really great starting points. I've given you a bundle of assets that you can use if you want to recreate my rocket ship. You're more than welcomed and encouraged to do that. Oops. Get this out of the way. All right. So if you look in this folder that I gave you guys, we have the start project file and the end project file. Here's the start. It's just literally a whole bunch of building blocks. Okay, the Fusion pieces are all there. If you use some creativity, you can start, figuring out the puzzle how to make all these things work. I've also given you the end. So this is the target. There it is. That's the target. If you wanted to, you don't have to make this if you don't want to. You're more than welcome to make whatever type of rocket ship you'd like. Okay.
Adding to that first project file.
Say again?
We're just adding to that first project file using Fusion and all that.
Well, I've given you a lot of pieces, a lot of custom pieces that will help you make this. Okay, but it's not everything. It's not everything. Okay. If you want to rebuild this example, go ahead and rebuild it. I think it's fun. There's the building blocks are there. I'll let you figure out where you want to go. If you want to make your own rocket ship, do it, man. I'm unleashing your creativity this week. I want you to infuse your own perspective and point of view on this assignment. Make me a rocket ship. Okay? Questions? All right, good luck. I'll see you guys next week.